Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
So now let's start practicals of OSPF. So first of all, I'm going to implement single area OSPF and with using very small diagram, right? I will teach you that what are the advantages of implementing single area OSPF and also what are the disadvantages of implementing single area OSPF first. And then after, I'll be teaching you about all network types as well as something related to timers, authentication, all basic practicals. So today we are going to perform all basic practicals of OSPF. We will talk about the basics of OSPF, and then from tomorrow and onwards I'll be going for some higher level practicals of OSPF, right? So let's go for this basics of OSPF first of all. So I'll connect some routers in a serial, like R1, R2, R3 is there, then R4 is there, and let's say R5 is also there, right? So I have taken 5 routers here. I will interconnect all these 5 routers together with using serial links as well as Ethernet links. In between some routers I'll be using serial links, and in between some routers I'll be using Ethernet links. So let me add this serial slot first of all, and then I have connected R1 with R2 with using serial interface. Then I will connect this R2 with R3 as well. Then I'll connect this R3 with R4 as well. You understand? And then finally I'll connect this R4 with R5, but this time I'll be using Ethernet link so that we can also perform the election of DR and BDR. If you want, then I can also take more than 2 routers in a single multi-access network. However, we can also perform DR BDR election with using 2 routers as well. It's not mandatory, it's not compulsory for us to have more than 2 routers in a single multi-access network. So is there any problem now? So this is going to be your diagram, and accordingly I'll do configuration and we will perform all practicals of OSPF, basic practicals. Let me start all routers, and then I'll be allocating an IP address in very simple way. Yes, in between R1 and R2 I'll be using 12 network, in between R2 and R3 I'll be using 23 sub network, in between R3 and R4 34 sub network, and in between 4 and 5 I'll be using 45 sub network. Then I'll be using loopback interfaces as well. Like here, let me show you 12.1.1 on R2, 12.1.2 on R3, 23.1.2 on R3 it will be 23.1.3 on R3 is S1 by 134.1.3, and here I'll be taking .4. Here I'll be taking an IP address like 45.1.4, and here I'll be taking .5. Understood? Good. Let me create some loopbacks as well. Like on R1 I'll be using 1.1.1, on R2 I'll be using 2.2.2, on R3 I'll be using 3.3.3, on R4 I'll be using 4.4.4, and on R5 I'll be using 5.5.5. Yes. Finally on R5, and here IP address will be 45.1.5. Fine. See, show IP route. Only directly connected networks are there. Show IP protocols. No routing protocol configured. And let's say router. Fine. Process ID. You can take any process ID number. Anything in between 1264535. As I said earlier on that here I'm gonna to implement single area OSPF only. So let's say I have taken one. Now you know very well the procedure that how can we allocate router IDs to OSPF. First one, statically you can configure router ID. Second, highest loopback. Third, highest physical interface IP. Active interface is IP address, right? So here I'm going to allocate its router ID manually, and router ID is going to be 1.1.1. Now to enable OSPF on interfaces, you have two options. You have two different options available. One by using network command, and also you can enable OSPF by configuring command under interface mode as well. You understand? I mean, you can also enable OSPF explicitly under interface mode as well. So here you are having two different methods by which you can enable OSPF on to interfaces of your devices. So this time I'm gonna to use like as you know network 12.1.1, and then I can take its wildcard mask because I just wanted to enable OSPF only on that interface who is having an IP address like 12.1.1.1.1 only, right? That's why I have taken its wildcard mask as 0.0.0 because in wildcard mask the meaning by zeros is what? Must match. Then I will define my area ID. Area ID is what? 0. So this time show IP OSPF interface brief. You can see that OSPF has been enabled on this interface. Then if you want to enable it on loopback, then you can also use this method to enable OSPF on your interfaces of your device. Like you can move under interface mode, and then you can say IP OSPF. You understand? IP OSPF is what? 1, and then area is what? 0. So I wanted to enable area 0 onto this interface. So in this, with using this method, actually you can enable OSPF under interfaces or onto interfaces of your device, right? So here you are having two different methods, unlike ESGRP, because in ESGRP we were having only one method to enable, and which was with using network command only. But here in OSPF you have two different methods to enable OSPF onto your interfaces of your device. One is by using network command, another one is as you know, right? So in this way you can enable OSPF. So let me show you IP OSPF interface brief. This command will be used by you to ensure whether OSPF is enabled onto interfaces or not, right? So on these two interfaces now OSPF has been enabled. Then you do one thing, move on R2, say router OSPF 1, router ID 2.2.2, and then because here I'm going to implement single area OSPF, so I can also say network 000 255 area 0. So you will, I mean the meaning of this command is what? That on all interfaces of this device OSPF will get enabled, right? So you can see that OSPF area 0 will be enabled on all interfaces of this router. Is not it? In same manner, I will move on R3. I'll say router OSPF 1, router ID is 3.3.3, network 000 255 area is also going to be 0. In same manner, I will move on R4. Router OSPF 1, router ID is going to be 4.4.4, network 0 0 0 0 245 245 and again area 0 here, area 0, because I want you to enable area 0 only here on all interfaces of this router 2. Now let's move on R5. On R5 as well, I will say router OSPF1, router ID is going to be 5.5.5 network 0 0 0 and it's wildcard mask now, and then area ID is what? 0. Show IP OSPF interface brief, you see. So now I have enabled OSPF on all devices here. After enabling OSPF, now let me show you routing table of R1. So it must learn all other routers loopback interfaces, as you can see here, 1 2 3 4. Even 555 will also be available, but might be it will take some time here, because the neighborship will take some time to come up into full state in between R4 and R5, because first of all they have to perform DR and BDR election. Because here I am using Ethernet connection, as I earlierly said that if you are using Ethernet connection, then of course by default DR BDR election will be mandatory for that network segment, right? So now you must have here 5.5.5, so you have learned it now. So is there any problem now? Fine. Now once again let me show you something here on R1. No router OSPF1. I have removed this OSPF once again from here. Show IP OSPF. Show IP protocol. Actually, is there any protocol now? Show IP OSPF database. Is there any database? I mean, is there anything available inside the database of OSPF? Because you have completely removed the process of OSPF from this device. Now you do one thing, move on R2 on its S1 by 0. I'm gonna to shut it down, so that R1 will not be able to form neighborship with R2 immediately. Are you getting my point? Okay. That's why I have shut it down right here. Now let's move again back on R1. I just wanted to show you that whenever you will enable OSPF on any device, it will immediately generate its own router LSA. As I said earlier on that wherever you will enable OSPF, it has to generate router LSA, and it has to store that router LSA inside its own database table. So this time on R1, I'm gonna do that once again. Router OSPF1, router ID is 1.1.1, and then say network 0 0 0, and then it's wildcard mask 245 245 245 245, and area is going to be 0. So show IP OSPF interface brief. You can see that on all these two interfaces OSPF has been enabled. Show IP OSPF neighbor. There is no neighbor. Show IP OSPF database. Inside the database, it is having its own router LSA. If router link state is stated here, it means this is kind of router. I mean, this is router LSA. See, the meaning by router link state is router LSA. Is there any problem now? Right now, you can see that it is having only one router LSA inside its own LSDB link state database, because it does not have neighborship with any other router here. That is why it is not having other routers router LSAs available inside its own database table. So it can also have other router LSAs inside its own database table, but after forming neighborship only. So you will never get the router LSAs in the database table of any router till it is not having neighborship with other routers, right? Yeah, you can find its own router LSA inside its own database table even without forming neighborship with other routers. So this time you can see that you can find its own router LSA inside its own database table. And as I said that in router LSAs, advertising router ID as well as link ID will always remain same. So how many links are there inside this router LSA right now? Only one is there. Sequence number is what? Because I said that to each LSA there will be a sequencing, right? A sequence number will always be allocated to your LSA. So whenever there will be any modification in your router LSA, whenever there will be any change inside your router LSA, it will regenerate whenever there will be any change on this router. Are you getting my point? Whenever there will be any change on this router, then it will immediately regenerate its own router LSA with the higher sequence number. Or you can say that its sequence number will always be incremented by 1 whenever any change will occur on this device now, right? So this time its sequence number is 1. You know why? Because I just enabled OSPF on this device, right? So this time it is having only one links information inside its own database table, inside this router LSA, as you can open it as well. Show IP, and one more thing, this router LSA is only for area 0, not for any other area. Now let me show you, show IP OSPF database router and 11111. You can see that router LSA which is generated by 1.1.1.1. So it is having only one links information, which is what? loopback. So it does not have, I mean, it is not having the information about serial interface. You know why? Because the line protocol is down at the end of R1. Show IP OSPF, sorry, show IP interface brief. As you can see that line protocol of the serial interface is what? Down, because we administratively shut down this link on another end, right? So its line protocol will remain down until on another end you says no shutdown, or until the another end is down, right? So now move on R2, say no shutdown, right? Say no shutdown. You will see that this line protocol of this interface will come up and also will form OSPF neighborship, right? So I will show you each and everything which is performed by OSPF during neighborship, during formation of neighborship. You see, line protocol have came up, at same time neighborship have also came up now. Show IP OSPF database. This time its router LSA will be incremented by, see, a sequence number. Still it is having its own router LSA, but this time you can see how many links are there? 3. How many links are there? Under link you can count them. Under link count you can see that how many links information are there. So how many links are there on R1? No, only 2 links are there on R1, but it is showing you 3. You know, you must remember one more thing here, that if your network type is point to point on any interface, by default on all serial interfaces your network type in OSPF is what? Point to point. So you must remember this rule of network type point to point, that if your network type is point to point, in that case it will create another entry for point to point connection, right, in its database table. So total number of, I mean, one serial link will be treated by default, one serial link will be treated as 2 links. By default serial link will be treated as 2 links. Let me show you, actually show IP OSPF database, it is showing you 3 links. However, show IP OSPF interface brief, only 2 links are there, but it is showing you 3 links. Now let me open router LSA generated by R1. Show IP OSPF database router generated by 1.1.1. So this time you can see, let me enlarge its window. How many links are there? 3. And now you can see one point to point connection, one point to point link have been created here in its database table by which another router is connected. And it is also showing you that what is the cost to reach this neighbor. It's not it. It is also showing you that what is the cost to reach this neighbor. So it found this neighbor here on this network, and the neighbor's router ID is this. And what is the metric to reach this neighbor here? 64. How will it come to know that okay, it is having neighbor on this interface or on this subnet? By looking at database table, how can you specify that okay, it is having neighborship? We are saying that OSPF is a fully linked state routing protocol. Then how can you say that okay, it is a fully linked state routing protocol without having a complete information, without having a topological database? Are you getting my point or not?
Yes.
Hello?
Yes.
Try to understand that if this entry is not there, how will you come to know that okay, R2 is connected with R1? By looking at its database. That is why inside its own database table, this information is also mandatory to have that which routers, which router is connected with which router. So in case of point to point, if your network type is point to point, then it will also create one point to point entry, because if your network type is point to point, means that in that segment you are having only 2 routers connected. If your network type is point to point, it means only 2 routers are interconnected in that segment. So which router is the second router? That information will be given by this entry. And because here now it is having 3 links information here, that is why total number of links inside this router LSA is what? 3. However, physically it is having only 2 links. Now as I said, see, I am not going to look at the physical diagram, but I will draw this diagram by looking at its database table only. I'm not going to look at the physical diagram. I will look at database table only, and I can draw this diagram very easily. Show IP OSPF database. As we can see here, that how many router LSAs are there? 5. 5 router LSAs are there. What does it mean that 5 routers are participating in this topology? In this area 0. 5 router LSAs specifies that 5 routers are participating in area 0 in this topology actually. One network LSA is also there, and we know very well that network LSA is for area 0 only. It means in this area 0 we are also having some DR and BDR as well. And this is generated by 555. It means it is generated by R5, right? So we will see that who is R5. We will see that, but later on. Let me draw this diagram by looking at its database table only. Now, I know very well that I am R1, and R1's router ID is what? 1.1.1. Are you getting my point or not?
Yes.
Show IP OSPF database router LSA. I'm gonna do open router LSA. That is why I have a specified router here, and that 1.1.1 generated by 1.1.1. See, 3 links information is there. One is your loopback interface 1111. One is your stub network, which is configured on your serial interface itself 12.1.0/24. Matrix is what of this interface?
64.
Because on serial link, on serial interface by default bandwidth is 1.544 Mbps. By default formula is 100 divided by bandwidth in Mbps, so it will definitely come as 64. Then how will you come to know that to whom it is connected? So it can show you here under point to point that it is connected with another router, point to point another router, and neighboring router ID is what? 2.2.2. And what is the cost to reach this neighbor? 64. So now we are connected with 2.2.2. Now you can open router LSA generated by 2.2.2.2.2. So say show IP OSPF database router and then generated by. So 222 is having 5 links information. However, we know very well that R2 is having only 3 physical interfaces, 1 loopback and 2 serial interfaces. As you can see here, one is loopback, subnet mask is /32, because you must remember that in OSPF loopback interfaces will always be advertised on /32. Now you can see that it is also connected with another router, and its router ID is what? 3.3.3. and what is the cost to reach this? 333 is 64, and it is also having one stub network which is 23.1.0, right? And it is also having one another router connected with it, which is R1, which it is also connected with our router as well.
Yeah.
It's not it, because all routers will be responsible to generate router LSA. So this R2 is showing us that it is connected with R1 as well as with R3. It is not connected with any other third router. It is connected with R1 as well as R3 only. So now from R1 to reach R3, what is the cost? 64. So we are having this information that R1 is connected with R2, R2 is further connected with R3. Then you do one thing, open router LSA generated by R3. Show IP OSPF database. Show IP OSPF database router 3.3.3. Now it is also having 5 links information. It is connected with 4.4.4 as well. What is the cost to reach this 4.4.4? Is 64. And then also it is connected with 2.2.2.2 as well. Of course we have already seen it, right?
Yeah.
Like R2 is connected with R3, right? So R3 is further connected with R4 as well. Is not it? And all others are what? Stub network. Is not it? I will show you, I will teach you that what is the meaning by stub network as well. But for now, let's go for the router LSA of R4 itself. Show IP OSPF database router generated by 4.4.4. You can see now how many links information are there? 4. Stub network is 4.4.4. Point to point. Point to point. Yes, it is connected with R3. We know very well that R3 is connected with R4, right? Then it is also having one other stub network, which is 34th network, and also it is having one transit network. Now, this is really important to understand this transit network. Remember that if you're inside the database table, inside router LSA, any network is specified as transit network. Any network is specified as transit network. Remember, it means your network type is broadcast over there, and you are having DR BDR election. You are having DR and BDR election. So we know very well that now designated router is what, 45.1.5, and router interface address is what, 45.1.4. this is our address, this is our address, and this is what, DR's address. Now if you want to see that in this transit network how many routers are there, in this transit network how many routers are there, because we don't know, because it will be having information about the DR. I mean, this transit network will be having an IP address of DR and its own IP address. So it is having its own IP address, which is 45.1.4, and also it is having the address of DR, which is 45.1.1.5. Now we don't know about the DR others. Might be that it is having multiple DR others over there. We don't know. We can't say anything right now. We are assuming that we do not have the physical diagram of OSPF right now. I mean, we do not have the physical diagram of this topology right now. So if you want to see that how many routers are connected in this multi-access network, in this transit network, for that you have to open route network LSA show IP OSPF database network and generated by 45.1.5, because this is DR. This is the DR address. Hey guys, try to understand, this is the DR, and DR will be responsible to generate network LSA. So say network and 45.1.5, because it will be generated by R5. You see how many routers are there? Test router 4 and 5. Only 2 routers are there. Are you getting my point or not?
Yes.
And what is the subnet mask running in between these 2 routers? /24, and this is the address of DR, and it is generated by R5. It is generated by R5, means we are also having one another router R5. So we can also open router LSA of R5. So now you see show IP OSPF database router 5.5.5. So is it connected with any other router now? No. So it has proved R1 is connected with R2, R2 is connected with R3, R3 is connected with R4, R4 is connected with R5. And in between R4 and R5 we are having the election of DR and BDR. Have you understood it or not?
Yes.
So wherever you will be having transit network, it means it will be mandatory for your devices to elect DR and BDR. And if you are having point to point, means there will be one another entry for point to point, but there will not be an election of DR and BDR.
तो जो ये अपने जो पॉइंट टू पॉइंट होता है उसके अंदर ही शो करता है कनेक्शन। साथ में R1
यहाँ पे LSA अलग हो गया ना, वो सोचो।
ट्रांजिट नेटवर्क मेट्रिक है।
What? This transit network, of course, because it is connected, it is reachable. I mean, this transit network is connected with FA0/0. So this is the metric of that interface. Let me show you. Show IP. See. So by looking at only one router, you can draw entire diagram.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.